This is my old Morgan Chicago 88 Vise. I've been using it on my outdoor workbench for about 25 years. It's been a great workhorse, except that the jaws have always been in really rough shape, and it was getting difficult to turn the crank. It also had a ton of backlash, so you'd have to turn it about a whole turn before the jaw would start moving the opposite direction. And I could never use the swivel feature because of rust jamming everything up. Morgan made vises in Chicago from 1920 to 1947, from what I could find out. So that means this vise is at least 79 years old and possibly up to 106 years old. They later moved to Aurora, Illinois, and then in 1970 the Milwaukee Tool and Equipment Company bought them out. Milwaukee still sells Morgan vises. I called them and you can still get the jaws for these old vises. You just have to specify that you want the U-shaped style jaws, which the old Chicago versions used. So I went ahead and ordered some. This Model 88 vise uses 4.5-inch wide jaws. Since these jaws are so beat up, I probably wouldn't have bothered restoring this vise unless I could get the new jaws for it. So I was pretty happy that I could still get the jaws for it. Whenever this ancient catalog was printed, you could buy this same vise brand new for $48. The price now, you can buy it from Zorro Tools, is $1,008 for the same model vise. So that made it seem like even more of a good idea to rebuild this old vise. Apparently these old vises were made of pretty good steel. It was a mixture of cast iron and steel, and they called it semi-steel. And it did hold up really well all these years, no cracks anywhere. I don't have video of me taking it apart, but I'll show as I put it back together. I'll explain how I got it apart, and you'll see how everything goes together. When I first got it apart, the grease had turned into something like Parmesan cheese, and it was a lot of work scraping it off of everything. Then I soaked the parts in kerosene and then used a wire brush by hand to get the rest of the grease off. And then I used various wire wheels and grinders to get most of the rest of the rust off of it. And I used files to knock off any high spots on the areas that needed to be flat. And then I soaked the parts in a tub of Evaporust, which did a pretty good job getting all the rest of the rust off. I didn't have enough to cover them completely, so I had to keep turning them different angles till everything was clean. After getting the rust off with the Evaporust, I rinsed them well and blew them dry. You have to work really fast though, because you start getting a flash rust on the bare steel as pretty much as soon as it sees air. I ran taps through all of the threaded holes just to make sure they're clean. You can see some of the flash rust forming on the steel. I didn't get this part dry fast enough. The Evaporust did us a pretty nice job though. You can see even in this recessed undercut groove area that the cast iron looks nice and clean. I straightened out this handle as well as I could by hammering it with a bronze hammer on an anvil. I masked off all of the machined areas I wanted to keep bare and spray painted these parts with some VHT caliper paint. When I was taking it apart, the jaws were the hardest thing to get off. No matter what I tried, I couldn't get the screws loose. So what I wound up doing was just slicing through the jaws lengthwise with a 3-inch cutoff wheel. And then that also wound up making a little slice in the screws. So the screws came out actually easily once I broke off the jaws. I knew I was getting the new jaws for it, so I didn't care that I ruined these old jaws that were in horrible shape anyway. The square-headed screws originally held in some pipe jaws. I never had the pipe jaws though, so I don't think I'll be needing these anyway. This is the collar that holds the Acme threaded shaft in place in the movable jaw. This pin was used to hold the nut in place. I guess what they did was hammer it in place and then bend it with a big hammer. I got that out by using a drift punch from the bottom side. I don't think these are original thrust washers. I think originally it had one 1/8 inch thick thrust washer. These are two 1/16 inch ones, and they were located on the wrong side of the casting. They were on the side where when you're backing off the jaw, it should be on the side where you're tightening it. So I'm going to replace these with a single 1/8 inch thick one. I don't think this T-bolt was original to the vise. Somebody probably broke the old one and made this one with it's just a thin washer brazed to a bolt. And it got really heavily rusted. It's a 1/2 inch coarse thread bolt. This T-bolt's a piece of junk. I think I'm just going to scrap it and make a new one. The shaft here is 7/8 inch diameter. And the recess here in the movable jaw is 1.5 inch diameter. The instructions on the paint say to bake it for 200 degrees for half an hour. I baked it for over an hour just to make sure that everything got up to temperature. These parts were too big to put in the little toaster oven, so I baked them in the stove. I baked these for a few hours since I know it's going to take a while for the cast iron to absorb all that heat. With the vent fan on, it didn't really seem to stink up the kitchen too much. So here's a close-up of that junky T-bolt that I want to make a new one. I found a 1/2 inch grade 5 bolt, which is about the right length, and it's a pretty good steel for welding compared to grade 8, which might be a little brittle. I'm going to make a custom washer part out of this 1/8 inch thick cold rolled steel. I drilled a 1/2 inch hole, then I countersunk it on both sides. Then I cut it out using a 3 inch cutoff wheel and a die grinder. I kept checking the fit and ground it until it fit just perfectly in here. To get a clean weld, I ground off all the zinc plating from the head of the bolts. Then I welded it with a MIG welder. I had to grind a little more of the head of the bolt off so that it could slide freely in the slot in the base. I painted it with some black Rust-Oleum. I used a 4 inch wire wheel to clean up the steel and make it look a little better. This is the pin that held the nut in place. You can see there's a gap between the hole and the nut. So to get rid of that backlash that I had before, I don't want any slop with the nut. I want the nut to be in one place with no room to move back and forth. So I decided I'm just going to make a custom pin out of this 5/16 grade 5 bolt. The extra width of the head of the bolt will take up that gap there. And when I pound it in, it'll bend the bolt slightly and kind of lock it in place, I think. I don't like how easily the pin fits in the hole. I'm worried it might work its way back out. So what I did was knock a bunch of dents in the in the side of the bolt to kind of upset the surface, give me a friction fit in the hole. I can't push it in by hand, so I think that's going to work out pretty well. I'm cutting down this cheap dollar store foam brush to make a little skinny foam brush. I squirted a little white Rust-Oleum into the lid, then I just used the foam brush to dab on some paint onto the tops of the letters. This is the first time I tried this. I think I might have got a little bit too much paint on the brush, but I started to get the hang of it after a while. I goofed right here at the end. I get some mineral spirits and a paper towel to wipe off the smudge. I'm using the wire wheel again to clean off this collar piece that goes on the shaft. The original set screw that goes into this shaft collar had kind of a shallow cone that barely protrudes into the hole that they drill in the shaft. So I found this other kind of set screw that has a longer nose on it, and I think that'll make a more secure fit to make sure that the collar can't ever work loose. And here's my finished homemade T-bolt. So here's the new thrust washer I found for it at McMaster Car. It's exactly the right size. It's 7/8 inch ID, 1.5 inch OD, and an 1/8 inch thick. It's also a special alloy with extra iron in it to give it more of an extreme load rating. If you haven't heard of McMaster Car, it's a great place to get all kinds of industrial hardware. There's a few high spots on the shaft. It's keeping the washer from going on. So I got a file and filed them down smooth. Also, the hole where the set screw locks into was a little buggered up, so I filed that area smooth too. To try to keep all this bare steel from getting rusty, I got this old can of Johnson paste wax. I'm just going to slather wax on all of it. Since this vise is going to keep sitting outdoors, I got this water resistant Amsoil grease. It's a synthetic grease, pretty high quality grease, and it actually is pretty water resistant. It's made for things like boat trailer wheels. I slathered a bunch of anti-seize compound on this set screw just to make sure that somebody 30 years down the road doesn't have a hard time getting it loose. With this new thrust washer in place, there's like zero backlash now in the shaft. It's just really snug. I also slathered some anti-seize on the threads of this T-bolt. Make sure it never gets rusted shut. And also on the threads of this shoulder bolt that holds the base to the fixed part of the vise. I decided to brush some of this water-resistant grease on the bare steel parts here where the two pieces meet together, just to make sure they don't get rusted together someday. You need a 1 3/16 inch socket wrench to get this screwed in tight. Smooth as silk. No wiggles. This was the hard way to do this because the threads didn't want to engage in the nut doing it this way. I guess because the long shaft was sagging at the end. So I turned it up on end and put it on a block of wood so the shaft's hanging straight down. Doing it this way was a lot easier. Another clue that this grease is pretty water resistant is that it's really hard to wash off your hands. At this point I was all done except for waiting for the jaws to come in the mail. Since the vise is going to be sitting outdoors, I slathered some car wax all over it. Helped the paint last a little bit longer. This caliper paint seems pretty nice, seems pretty durable. And I put another layer of this Johnson paste wax on the bare steel where the jaws are going to fit, just to make sure that part never gets rusty. Yay, the new jaws arrived from Milwaukee. They look great. They're serrated and they're made of tool steel. Looks like maybe they're case hardened or something. They came out real nice. To keep these from getting rusty, I'm going to slather more of the paste wax on them. The jaws are machined to be a real tight fit. You actually have to pound them on. So I don't mess up the new jaws, I use this bronze hammer to do it. And this is a real good, important place to put some anti-seize to make sure these screws can come out again 30 years down the road when somebody's trying to get them out again. Yeah. I put a piece of aluminum in here to squeeze down hard and then check the pattern of the serrations. It looks like it's a nice even squeeze all the way across. It's great that there's no backlash now, and I can just spin this thing open or close with my finger. This vise weighs 72 pounds, so it's not exactly easy to carry around. I always like this vise because it has a huge opening, and it's also got a pretty big distance from the jaws down to the beam. Gives you a lot of working room. It's pretty satisfying seeing this vise all back together looking like new again. I know I'll get a lot of good use out of it, and it's probably going to be around for another 80 to 100 years. Hopefully you enjoyed this video, and hopefully it'll give you some tips on rebuilding a vise if you try to do one of these yourself. Thanks for watching.